Hey guys, my name is Trevor Sullivan, and I am a solutions architect with StratusGrid. StratusGrid is an AWS Premier Consulting partner, and we're also an ISV that has a software as a service product called Stratosphere. You can head out to our website at stratusgrid.com and click on this little Stratosphere link here if you're interested in learning about it. It's essentially an enterprise and private equity focused cost optimization tool that helps you to identify cost savings opportunities inside of your AWS accounts and go ahead and implement those cost savings opportunities. And you can really just unlock a lot of value from your usage of the AWS platform. So feel free to check out our website if you're interested. Now, the topic that I wanted to cover in this particular video is actually around the Amazon DocumentDB service. We're going to be looking at this diagram here and talking through how we can expose a DocumentDB instance to the outside of your VPC so that if you are using a laptop or development workstation, like the physical desktop workstation that I'm sitting at right now, and I want to be able to access a DocumentDB or MongoDB compatible server in my AWS VPC using local tooling that I have on my desktop system, I wanted to show you how to set up a connection in your VPC to accommodate that. Now, one of the things you might think about when you're dealing with databases is that you don't want to necessarily expose your database instance to the outside internet. And in general, that's a good security practice. However, the Amazon RDS service does allow you to create public endpoints for your RDS instances. Plus, other data services like Amazon S3, for example, by default has a public API endpoint. So if you're storing data in S3, then you're going across public APIs that are using TLS encryption, of course, for the security in transit or encryption during transit. And also other services like Amazon DynamoDB, for that matter, also are using public endpoints unless you explicitly go through and set up a private endpoint in order to access your DynamoDB service. So DocumentDB, unfortunately, does not provide a public endpoint out of the box. And so if you're wanting to use, again, local tooling on your developer workstation, then you're kind of SOL. However, we are going to take a look at a little solution here that actually allows you to access the DocumentDB instance using your local tooling. And essentially what we're going to be doing is setting up a proxy service. And this is not an HTTP layer 7 proxy. This is actually going to be a layer 4 proxy, just a TCP proxy that we essentially use to forward network traffic from outside of the VPC to our DocumentDB instance. So in this diagram here, what we essentially have is our AWS region, right? So VPCs are regional resources. I could have a VPC in US West 2 Oregon or US East 1 North Virginia or any other region in AWS. And then I can break down my VPC into individual subnets. And each of those subnets are going to belong to a specific availability zone within that particular region. So as you may know, in AWS, each region is actually broken down into multiple availability zones. That's what provides kind of local regional redundancy across AWS data centers. So I could have a public subnet that has direct access to an internet gateway here so that I can have publicly routable IP addresses associated with something like a Fargate container or an EC2 instance or certain other types of resources in AWS that provide support for having publicly routable IP addresses. I might also have a private subnet down here where any instances of containers or EC2 instances that I deploy down into this private subnet will not be able to get publicly routable IPv4 addresses. They'll only be able to get private addresses in the allocated CIDR block that I have for that particular subnet. So generally speaking, you would have a DocumentDB instance deployed into a private subnet. There's not really much purpose in putting it into a public subnet because it can't get a publicly routable IPv4 address anyway. So you would put your DocumentDB instance in that private subnet there, and then that is going to listen on TCP port 27017 by default. If you want to override that default port, you're more than welcome to do that in the instance configuration, but that is just the default port that MongoDB listens on. And then what we would do is have in the public subnet here, what we're going to do is deploy an AWS Fargate container, which allows you to deploy a container-based application without having to deploy any virtual machine infrastructure to support that. So I don't have to create an EC2 instance. I don't have to install the Docker engine or anything like that. I can literally just hand a task definition to the ECS service, and it'll go out and run my container. And so what we're going to be doing is using this application called Easy Proxy, which is an open source TCP proxy that we can use to forward network traffic from the publicly routable IPv4 address on that Fargate container to the internal interface. And then that internal interface can then forward traffic to the DocumentDB's private network interface. So for example, I might have an IP address internally of something like 10.5.5.109 or something. And then on the internal private interface, this Fargate container can take that traffic and send it over to whatever the private IP address of the DocumentDB instance is. Now, there's quite a bit of setup work that goes into this. Unfortunately, it's a little bit complicated because you've got things like your security group rules that you need to pay attention to. You've got your task definition that you use to actually launch a Fargate task, and you have to set up all the different configuration options inside of that task definition, and it can be a little bit overwhelming, especially if you're new to containerization. Also, you'll have your route tables that you'll want to make sure are set up properly. Although in AWS, you typically have a default VPC in each region that has public and private subnets. So we're not going to talk about setting up the VPC and everything. But if you don't have a VPC in a particular region, you can also go to the VPC dashboard, and they actually have a template that you can deploy that has public and private subnets along with the internet and NAT gateways and everything to support that. So all that stuff can be kind of set up for you fairly easily. Now, let's talk a little bit about the gateway system that we have over here. So for the DocumentDB instance or any other private workloads that I have running in this private subnet here, if I need them to have outbound access to the internet for some reason, like maybe I have a container that needs to be able to run periodic updates or something like that, and I need it to be able to route out to the internet to get updates, then you can set up a NAT gateway. The NAT gateway actually gets deployed into the public subnet because the NAT gateway has to be able to get a publicly routable IPv4 address. But then what you do is in your route table that's associated to your private subnet, you set up a rule on that route table, a routing rule that will basically forward any traffic destined for the internet through this NAT gateway. And then similarly, the route table that's associated to your public subnet is going to have a routing rule in that route table that sends any traffic destined for the internet directly to the internet gateway. And of course, whatever workload is running in that public subnet will also need to have a publicly routable IPv4 address associated with it in order to use that internet gateway. So that's just kind of the basic setup of a VPC environment here. Now, one of the other things that we need to make sure that we do is set up our security group rules. And so what we need to do from the security group's perspective is make sure that whatever security group we have associated with our AWS Fargate container here has access to TCP port 27017 on this DocumentDB instance. So we could either do that based on the source security group by just adding them both to the same security group and then adding a rule into that security group that allows the security group that it's associated with to actually access any host on TCP port 27017, or we could even potentially have separate security groups where we have one security group for the Fargate container, we have one security group for the DocumentDB instance down here, and then we would have to set up rules a little bit differently there, but we could also do it based on a CIDR block. So whatever security group we have associated with DocumentDB instance down here could just say allow any private traffic inbound from 10.5.5.0/24, and that would allow any workloads that I have running in this public subnet here to route traffic and access port 27017 on this private subnet here. So there's a lot of different moving parts we need to consider. Now, one of the complex parts that we have here as well is just setting up the Fargate container itself. So the application that we're going to be using, as I mentioned, is Easy Proxy. And I just want to show you the page for that over here. This is a application that's been built in Rust. So what you can actually do is just install the Rust tool chain, and you can install Easy Proxy directly from the crates.io registry where Rust applications are stored and libraries are stored and things like that. So if you head out to crates.io right here and just do a search for Easy Proxy, you can see that it's hosted out here. It hasn't been updated for quite some time, but it's a really simple application. Literally all it does is it forwards network traffic from one interface to a different interface on a different port, and that's really all it does. So that's perfect for our use case here, where we just need to proxy network traffic from a public interface to an internal private interface. Now, in order to run this application, I'm going to take a little bit of a unique approach. So normally what you might think you want to do in an architecture like this is to build a custom container image that has the Easy Proxy application installed into it, and then you would deploy your AWS Fargate container using that custom container image that has the Easy Proxy application built into it. I'm going to take a little bit of a different approach though, because I don't want to have to build a custom container image. I want to just be able to deploy a Fargate container using a publicly accessible container image. We're actually going to be using one from the Microsoft Container Registry. It's going to be a PowerShell based container image. But then what we're going to do is write a really simple PowerShell script that just has a few sequential commands inside of it that will install the Rust tool chain. It'll install the Easy Proxy application from the crates.io registry, and then it will actually instantiate the application. It'll run that application as part of that entry point script. And so what we can do is basically wrap up that entire script and configure it as a custom entry point in a stock container image so that we don't have to worry about building a custom container image for this specific purpose. So I've actually already put that script together right over here. So essentially what we're going to do is launch a brand new PowerShell container image, which is over at mcr.microsoft.com/PowerShell. And you can actually find that over on the Docker Hub. So if you head to hub.docker.com and just do a search for PowerShell here, they used to have a listing on here, but maybe they got rid of it. But the place that you want to get the PowerShell container image from officially is from the Microsoft Container Registry. And again, it looks like they got rid of the listing here, but they used to host it on the Docker Hub, and they actually used to have a listing here, even though they hosted it over on mcr.microsoft.com anyway. But just so you know, that's where the container image is going to be coming from, not technically from Docker Hub, but Docker Hub here just kind of represents a public container registry where we can grab a container image from. So what we're going to do is basically embed this little PowerShell script as the entry point to our container. So what it's going to do is it's going to just update all the base dependencies for starters. So if there's any out-of-date packages in there, it'll just run an upgrade process on any base packages that are built in. Then we're going to install curl as well as the GCC compilation tools. And we need GCC because when we try to do a cargo install on a crates.io package and actually compile that application from source code, from Rust source code, we actually need some of the utilities like the linker. I think it's LD is the binary name that comes from the GCC package. So that's why we have to install that. And then we also have to install curl here because we need to use that to download the installation script for the Rust tool chain that we're going to use to get the cargo binary, which is what we use to install Rust packages from the crates.io registry. And then once we've installed the Easy Proxy application and it's been compiled from source, we can access that under the home directory, which in this case is going to be the root user, under the .cargo/bin directory, and we can just invoke the Easy Proxy binary. We can listen on all IPv4 interfaces on a specific port. We're just going to hard code that into our script here so that we're listening on a specific port. We could actually change that maybe to 27018, just so that we can set up different security group rules, one that targets the actual MongoDB port, and then one that targets our custom port. So when we connect our client application to the proxy container, we're actually going to connect to it on 27018, but then this will forward it to the MongoDB server on port 27017, which again is the default port, but you could override that on the DocumentDB instance configuration when you deploy it if you'd like to. Now, the other thing that we're doing here is we are using PowerShell's environment variable syntax here to retrieve an environment variable that we can set when we actually instantiate the container, or in this case, it's called a Fargate task that instantiates the container, but we can configure an environment variable on there that has the DNS endpoint of our DocumentDB instance that we want to connect to. So once you've deployed a DocumentDB instance, I'm not going to go through that process because it takes several minutes to set up a DocumentDB instance. But if you go down to the connectivity section right here, it gives you the directions to connect to your DocumentDB server. So this DNS endpoint that we have right down here is actually referring to an internal endpoint on the private subnet. So we can't access this DNS name from outside. I can't directly access that across the internet from my local development workstation. I actually have to plug this in to the proxy container that's deployed into our VPC. And then because the proxy container is on the same VPC where this DocumentDB instance resides, I will be able to resolve that DNS name against the Amazon provided DNS servers and ultimately access the DocumentDB instance. So we provide it as an environment variable so that if we want to connect to different DocumentDB servers, like of course the DNS name for your specific server is going to be different based on the name of the DB instance that you provide, as well as the kind of random text that they generate as part of the DNS name as well. So that just makes it a little bit easier for us to pass in the DNS name of the DocumentDB server when we launch the Fargate task. Now, you might be wondering, well, how do we pass in this PowerShell script into our container, right? Don't we have to build a custom container image and then inject this PowerShell script into that custom container image and then launch the container from that custom container image that we've built? Well, the answer is no, you don't have to. There's actually an easier way to just use the default container image without having to go through the process of building a custom one, and then just using or embedding this PowerShell script directly into that container. So what we're going to do is actually launch PowerShell. I'm going to show you just locally how we would accomplish this. So when you run PowerShell, this is the cross-platform version of PowerShell called PowerShell Core. But when we do PowerShell, PWSH, there's actually a parameter on the PowerShell binary itself called encoded command. And what this allows you to do is to do UTF-8 or UTF-16 rather encoding on a string of text. So what we're going to do is basically take this huge script that we have here. It's actually not that big of a script, but we'll say it's kind of huge because it's more than one line. And what we'll do is run a UTF-16 little endian encoding, LE encoding on it, and then we'll just pass that singular string into this encoded command parameter. So we take this base64 string that's actually a multi-line script, but we just pass it in as an encoded command directly into the container rather than having to inject this script as a file into the file system of a custom container. So this just saves you an extra step. And I actually really like this because it just avoids the additional step of having to build a custom container image. So what we're going to do is go ahead and take this code here and run a base64 encoding on it so that we can create what's called a ECS task definition that allows us to launch this Fargate container here. So if I just go out to the web and search for base64 encoder, there is this little green icon site here. There's base64 encode and base64decode.org. I'm just going to go to the encode one here, and then I'm going to paste in my script here. And we want to do UTF-16 little endian encoding. So that's the encoding type you'll want to choose. Then you'll just click on encode. And this base64 string that we have here is what we're going to pass in to our PowerShell container that we launch. So now that we have that script encoded in base64, what we're going to do is head out to the ECS service here. And again, I've already got my VPC with my DocumentDB instance set up and everything. So hopefully you have a little bit of background knowledge on that. If not, I'd encourage you to go out and study VPC separately. But just to show you really quick under VPCs, I'm using this default VPC here with a private IPv4 CIDR block. And then if I take a look at my subnets here, all these unnamed subnets right here are associated with this default VPC here, and one of these subnets is where my DocDB instance has been deployed to. And again, it does not support publicly routable IPs, so it's not going to have a public endpoint. But the Fargate container that we launch is going to have one. So over under the ECS service here, you can see I've already created a cluster here, but you can just go ahead and create a new one. I'll just call this stratusgrid-fargate, and we're going to use the Fargate launch type for this here, and just hit create there. And then for the task definition here, I've already created this proxy task definition right here, but I'm going to show you kind of from scratch how to go about creating a task definition that works as a proxy like this. I'm going to call this stratusgrid easy proxy, just to give it a unique name. We're going to be using the Fargate launch type here because we don't want to have to worry about setting up all the ECS infrastructure, basically EC2 instances joined to our ECS cluster. We're going to be using just a 64-bit architecture here. You could choose ARM-based architecture if you wanted to as well. You can also reduce the amount of virtual CPU. So I actually went all the way down to just 0.25 of a virtual CPU, but just to make sure that the compilation of Easy Proxy is a little bit faster, I'm going to go ahead and assign 1 vCPU and 4 gigs of memory, but I was actually successful assigning 0.25 vCPU with half a gig of memory. And it did take a few minutes for it to compile Easy Proxy and all its dependencies, but it did eventually work. But for the sake of time on this video, I'm just going to choose a larger size here, even though it'll cost a little bit more. And then down under the container configuration, this is where we're going to plug in some details. So we're just going to give the container a name. It just has to have a unique name inside of the task definition, because a task definition can actually have more than one container. The name that you actually put in here doesn't really matter at all. But the image URI here, this is going to be the PowerShell container image that we're going to use that just has PowerShell pre-installed inside of it so that we don't have to worry about installing PowerShell. All we're going to do is pass in our encoded PowerShell script into the PowerShell binary, launch that installation and setup process, and it'll be good to go. Now down here under the port mappings, remember that in our PowerShell script right here, we are going to be listening on 27018. So we need to make sure that we are exposing port 27018 TCP outside of this container. And then the Easy Proxy process is going to go ahead and connect to the MongoDB target on 27017. All right, we can also add environment variables here, but we can actually do that at the override time when we actually launch the Fargate task as well. So if you want to, you can actually just plug in a kind of placeholder here. So we could say MongoDB target and just plug in like empty or something. Just want to make sure that that matches correctly, MongoDB underscore target. Yep, that looks good. And then by default, you can use the CloudWatch logging capabilities here, which is kind of nice because then you can actually see what's happening inside of the container. And I don't think we really need to worry about too much else right here, because when we actually launch the Fargate task, that's when we can specify the network configuration as far as where we want to deploy it into. So what I'm going to do now is just create this ECS task definition. And then what we want to do is launch one of these tasks out to our Fargate container, or as a Fargate container to our cluster here. And remember that with Fargate, when you create a cluster here in ECS, the cluster is not like a big cluster that has a whole bunch of compute instances joined to it. It's literally just a logical entity that allows you to target different tasks and services at that particular cluster. But as far as actually setting up the compute capabilities for running your container, all of that is fully managed for you thanks to the Fargate service. But you still have to create this kind of logical cluster entity in order to deploy a Fargate task. So you can either start from the task definition, or you can go over to the cluster itself and then go to tasks here and say run a new task. But I'm going to go over to task definitions here, choose my task definition, and then choose the version that I want to deploy, because you can have multiple versions here. And so what I'll do is just say deploy, run task, then I'll choose a cluster. So I'll choose the one that I just created here called stratusgrid Fargate. Actually, one other thing before we get into that, On the cluster itself, I'm going to hit update cluster and say add capacity provider and then choose Fargate spot here. So that will allow me to use the discounted rate for AWS Fargate and actually get up to a 70% discount. So when you're running this container, it can actually be very, very inexpensive if you're down at that 0.25 virtual CPU and half a gig of memory. So make sure that you assign that Fargate spot capacity provider to your cluster as well. So now we'll come back to the Easy Proxy task definition here and say run task. And then we'll choose our StratusGrid Fargate cluster right here. And I'm just going to leave this at the default because the capacity provider strategy is determined based on the cluster. And then I'll just choose Fargate spot since we just added that to our cluster as an option. And then down here, you can see these are grayed out because I already specified the task definition family and revision number that I want to deploy. So that's just grayed out because I've already used that as input to this wizard here. And then down here under networking, this is where I can choose my VPC. I'm going to use this default VPC that I have right here. And then if I want to, I could limit it to a specific subnet here, but I'm just going to allow it to use any of these subnets. I'm also going to use an existing security group here, or let's actually create a new one just for this purpose. I'll call this StratusGrid-Easy Proxy. And then for the inbound rules here, I'm going to create a custom TCP rule that allows me to target 27018 because that's the listener that we're creating. And then for the source here, I can specify a custom CIDR block. So I'm going to choose 216.0.0.0/8 as the CIDR block that's allowed to access this port. And of course, I could get even more specific with that, like doing a /16 or a /24 or even a smaller CIDR block than that. And that will even further limit which IP addresses are able to access this proxy service. But we still have TLS and we still have to authenticate anyway. But this is just an additional security layer that we have to do blocks based on IP. Now for public IP here, I want to make sure that my proxy container here has a public IP in addition to the private IP that we have on the VPC. So you want to make sure that you leave that public IP setting set to on right there. We don't need any local storage for the container. For the task overrides here, you can assign permissions, but we don't need any permissions to AWS APIs because this is literally just proxying network traffic. But then down under the container overrides here, this is where when you actually take the task definition and then launch a task from that task definition, this is where you can specify things like the environment variables as well as the command override. Now, we could have embedded the command. I actually meant to embed the command in the task definition. Normally you would do that, but what we can do here is specify PowerShell-encoded command, and then we can pass in the huge base64 encoded string that we have right here. And so what this is going to do is when this container is launched, it's going to launch PowerShell with the encoded command parameter, and then it's going to take everything after that and base64 decode it, and it's actually going to execute that script on the fly as the entry point to our container here. So down here for MongoDB target, we already provided a default empty value for that. So now what I'm going to do is go over to the DocumentDB service here. I'm going to navigate down to my cluster instance here, and we're just going to grab the DNS name for that instance. And then back here, we're just going to paste that in. Also, I did want to note that this is the command override, not the entry point override. And I might actually need to come back and actually override the entry point if this doesn't work. Docker has two different things. It has the entry point and the command. And since there's already a PowerShell entry point for the PowerShell container, I might need to actually come back and update the task definition. But let's go ahead and just give this a try for now. For the security group description, I'll just say Easy Proxy TCP forwarder for DocumentDB. And let's try to create this again. Looks like there was a second entry here, so let's go ahead and remove that and create. And so this is going to go ahead and run a new task. And now we want to kind of monitor that task to make sure that it actually does come up and running. So under our StratusGrid Fargate cluster, under the tasks tab right here, you can see that we have a new task that is currently in the provisioning status right here. And then if we go over here and check it out, we have a publicly routable IPv4 address along with the private IP address on our VPC. So that kind of matches what we were showing up here, where we want to have a publicly routable IP that has direct access inbound through the internet gateway from our development system over here, but we also need to have that private IP address so that it can route traffic directly over to the DocumentDB instance. All right, so we'll give that a second to come up and running, but over here under the logs, we can actually see what's happening inside of the container. And so it looks like, based on these logs right here, everything is actually running as expected. So we can see the apt logs here doing updates to just the base packages in the container image. And then eventually, we see a little bit higher up there that the Rust compiler and all of the supporting utilities for the Rust toolchain like Cargo and Clippy and Rust docs and things like that are getting installed. And so we can just refresh the logs here and kind of see the latest message as far as what's happening here. And after these dependencies have all been compiled, it'll get to the last line of our script, which is actually launching EasyProxy right here. So at the moment, it's done installing the Rust toolchain and it's actually compiling all of these dependencies for EasyProxy itself. And then as soon as that compilation is done, then it will actually launch the proxy. So now what I want to do is make sure that the security group that is associated with my DocumentDB instance allows inbound traffic from the different security group that we created for the Fargate task here, right? Because I created a dedicated security group during the launch wizard for the Fargate task for our proxy here. So what I need to do is go find on the DocumentDB instance, go to configuration and find the security group that is associated with that DocumentDB instance, and then take a look at the rules for that security group. So let's go down to inbound rules here. And if we check out our inbound rules, you can see I do have a couple of TCP rules here allowing inbound access on 27017, but that is based on the source of itself. So we would have to have the same security group associated with the Fargate task as well, or we would have to be coming from 216. But remember that the traffic is not coming from our public IP address directly. It's actually coming from the Fargate task. So what I'm going to do is add in another inbound rule that actually uses the other security group ID associated with the Fargate task as the source of IP traffic and allow it to access 27017 on the DocumentDB instance. So what I need to do is actually find out the security group ID of the one that we just created, and I believe that is going to be this one right here. So we'll go ahead and copy that security group ID, and then we'll come back to the security group that's associated with our RDS or our DocumentDB instance, and I believe that's 0963. Let me just double check that, 0963CA. Yep, that's it. Go to inbound rules and then edit inbound rules. And we'll just add another rule for 27017. And then the source is actually going to be StratusGrid EasyProxy. So we didn't even have to copy it because it's auto-completing right here. And we'll just say DocumentDB access from EasyProxy Fargate task. And then we'll go ahead and hit save rules there. And so now when the Fargate task spins up, it should now have access to port 27017 on the DocumentDB instance. As you can see, we are using that default port here on the DocumentDB instance here. All right, so we've already set up the rule. Let me just check my public IPv4 address really quick to make sure it's in the 216 block, and it looks like it is. So as soon as our task comes up and running here, we should be able to test connectivity with some local tool. So as you can see here, when we refresh our CloudWatch logs for this Fargate task, the final message here is basically the final step of our PowerShell script, which is just launching EasyProxy itself, and it is now proxying from 0000, which is all interfaces, 27018, to this DNS address on 27017. So now what we need to do is use a tool to attempt to connect to our server. In this case, I'm going to be using MongoDB Compass here, but there's lots of other open source tools and libraries that you can use to build your own applications in order to connect. So what we're going to do is, instead of connecting directly to our DocumentDB instance, we're actually going to take the public IPv4 of our proxy container, and that is going to be the IP address that we are ultimately connecting to here. But we also want to take a look at the directions over here for connecting to the DocumentDB instance, because we do need to download this PEM file here. So let's go ahead and just copy the URL and open that up in our browser here to download that file locally. And then we'll pass that into the tool as well. And then we also need our password here. So I've already set up a username and password when I launched this instance that will plug in as well. So we're going to connect to this IP address right down here on 27018 instead of 27017, because this is our proxy port. And then under advanced connection options here, you do have to check this box for some reason for direct connection. I don't know exactly what that does, but I did find out that you actually do have to check that. And then I'm going to plug in my username and password, which I think is just ASDF1234. And then for TLS and SSL, we want to choose our PEM file for the certificate authority that we are validating against. So I'm going to come over to my downloads folder here and choose that. And then we're going to go ahead and choose TLS, allow invalid host names. And we have to do that because the DNS name that we are connecting to doesn't actually match what our cluster is. So because we're connecting to this IP address right here, we are not going to be able to validate the certificate against the host name. So we have to choose this option that allows invalid host names. So let's go ahead and hit save and connect here. I'll just call this SG proxy test and hit save and connect. And sure enough, you can see we are connected to this DocumentDB instance. So I can now do things like creating a database here. I'll just call this Stratus Grid. We'll create a collection here called people. We'll say create database. I can go ahead and start adding items into this collection. So if I do add data, insert document, I'll just go ahead and add a field here like first name Trevor and last name Sullivan. And we'll go ahead and just insert that document into our DocDB collection here. And as you can see, that works perfectly fine. So this is MongoDB Compass, a graphical cross-platform tool. I think it's built in Electron because it kind of looks and feels like an Electron application. But this just kind of proves out that we are indeed able to access our DocumentDB cluster from our local development system, right? I'm going across the internet to the proxy container that we set up in AWS Fargate. Let me just bring up this diagram here again really quick. So we're coming in from over here, from a 216 address, going over here to our public IP address on our proxy, and then that proxy, easy proxy, is just forwarding the traffic to the DNS endpoint, which is private for this cluster here on port 27017, and it's able to then connect. So if you were to not choose the option that does the validation of the certificate's DNS name, I just kind of wanted to show you what that looks like here. So let's hit edit on the connection, go to TLS right here. And then if we uncheck this and actually do hostname validation and try to connect again, you're going to end up getting an error message saying that the hostname on the certificate doesn't actually match. At least it should show up right here after a moment. So just make sure that you check that. Also make sure that you check the direct connection box on the general tab. Otherwise, for some reason, the connection doesn't work either. But basically, this is how you can set up a TCP layer 4 proxy that can forward traffic to your DocumentDB instance. Generally speaking, you're just going to want to do this for development purposes. You're probably not going to set up a production application like this because probably you're going to have EC2 instances that are in the private subnet along with your DocumentDB instance that are running your application and then exposing that through some kind of public-facing API. But for development purposes, if you really do want to set up a DocDB cluster to develop against and then use local CLI tools or graphical tools to connect to it, this is a way that you can accomplish that. So you can use this technique for other types of applications too. So DocumentDB is just one example, but there's other applications out there that only have private endpoints in a VPC environment. And so anytime that you need to do layer 4 proxying, you can certainly do this. Also, I wanted to point out that Easy Proxy is just one application that you can use. It is a little bit out of date, but again, it's a very simple process to proxy network traffic. It's just kind of a simplistic thing to do. So it's not really like that application needs a whole lot of updates, but I did want to also encourage you to potentially research other applications that could work as a TCP proxy as well. The reason that I ended up using Easy Proxy for this particular demo was just because it has a couple of CLI parameters that has kind of the listener address and port, and then the target, and there's not really any configuration that you have to do. You don't have to create a configuration file and then put that on the file system or anything like that. So because they're just CLI parameters to do the layer 4 proxying, and there's only 2 parameters that you have to worry about, that just made it a really easy process as well. And again, you can use this same technique where we did base64 encoding to encode a multi-line complex PowerShell script into a single base64 string that we just passed into a PowerShell container. We didn't have to worry about the whole process of building a custom container image and then uploading it to a private ECR repository and then setting up the permissions on the Fargate task for the task execution role so that it has access to pull the custom container image from that ECR registry, right? So we bypassed all that complexity by simply passing in our PowerShell script for our application here as a command argument to the container itself directly inside of the task definition configuration. So that's a really handy technique that I would encourage you to just keep in the back of your head anytime that you need to deploy some kind of semi-complex script, but you don't necessarily want to go through the process of building a custom image for it either. All right, so I think that's everything I wanted to cover in this video. Again, make sure that you subscribe to our channel, leave a like on this video if you learned something new. Thanks so much for watching, and we'll see you in the next video. Take care.